then we have to make sure that we reinforce either the double joist, or make sure we nail the double nail together. So that's what we would call point load or concentrated load at that location. Deflection. Deflection is the term that means this actual distance here. Once you apply load, and remember, once the bend, the actual distance here is the deflection. Okay, how much is, not how much it bends, but what's the resulting distance of that bend. That's what we call deflection. So deflection is usually measured either as a distance, so in inches, or it's measured as a ratio of the length. Okay, so you might hear the term L/360, L/480. If you look at the building code in Part 9, the minimum deflection criteria, that's how they call it, would be L/360. Okay, so L being the length of your member in inches. So if you take 20 feet, convert that to inches divided by 360, that'd be the maximum amount of deflection that that 20-foot joist would be able to have. Okay. So L/360 is the code minimum for live load. We'll talk about what live load is and all that stuff after, but you'll see all of our span charts, and it's pretty much industry standard that we kind of raise the bar a little bit, and we make our minimum deflection L/480. So the higher the number, the stiffer or the less amount of deflection we actually have. Okay. So that used to be really the governing thing to design for. There was some changes in the 95 building code that made vibration now the most critical thing. So we'll see a little bit later what affects vibration and how we control that. But deflection is still an important measurement tool, because that's going to often have an effect on our floor finishes. If you've got ceramic tile, particularly some real large ceramic tile, there might be some deflection limits that you want to set so that your fancy terrazzo tile that's imported from Italy isn't going to crack. Okay. So that's what deflection is. Shear, we spoke about that. It's the actual force of the member wanting to slice off here. So you're applying a bunch of load on here. So there's a bunch of transfer of load happening here. Meanwhile, the wall is resisting, so that effect there is called shear. Okay? Again, most critical when we're talking about beams. Reaction, you'll hear that term a lot. That's the magnitude of load at that support point. Okay? So if we've got 100 pounds per linear foot, PLF, so on every foot, we've got 100 pounds on that joist, okay? And the joist is 16 feet long, so half of it goes here, half of it goes there. So we have 8 feet at 100 pounds, so 8 times 100 would give us 800 pounds of reaction right here. Okay? So we have to make sure that we either have a joist hanger that can support 800 pounds, or we have enough bearing length that can support 800 pounds. Okay, so that's where the reaction becomes an important thing to consider in design. We spoke about the whole roof structure thing. Okay, so when we're talking about an I-joist, using an I-joist as a roof, it's important that that peak be a beam and not just a ridge plate or a ridge board, such as this. Okay, where it's not a structural element, it's just kind of a filler piece for some nailing. And then you usually have either a collar tie or some other webbing in there that would usually bring on some intermediate supports in there, kind of the old school stick frame stuff. Okay. Or the other way would be roof trusses, which is whatever kind of geometry within. It's got plated connections, and all of that load gets transferred to the exterior walls most of the time. Okay. So 3 different kind of roofs. Very important to understand the difference, because if you have a window over here with a header that you need to size, that's going to make a big impact on how that roof is framed, right? We've got this here, right? We've got an I-joist roof, and I've got a header down here, right? And that's a structural support point up there. Well, then half of the distance is going here, half of the distance is going up there. So that means if I've got 20 feet, half of it is 10, so that means 5 feet of it is going here, and 5 feet is going at the peak, okay? Whereas if I have this, same 20 feet, well then 10 feet of it is coming here, that's where it's real important to understand how the roof is framed. Particularly important when it comes to renovation projects and things like that, because you get into some older buildings that you want to leave or something, and who knows how the heck it's framed, right? So it's important to understand how that's done, because if you've got this kind of a system with a whole bunch of mismatch, it becomes real hard to kind of gauge what's happening here, because there's distribution of load in different directions. So that's where it might be wise to get a project engineer involved on the job like that. Okay. Live load. Everybody tell me what live load is? Without reading the definition? Live load would be any non-permanent load. Okay. So the weight of people walking on the floor, the weight of your furniture, your fridge, your stove, your bathtub, anything that isn't permanent, that's what we call live load. Okay. And live load, there are charts in the building code that dictate or that stipulate what the live load is depending on the building's use. So the live load in a residential home is much different than the live load in a library. Okay, you're carrying thousands of books, whereas in a residential home you're carrying people. Okay, so for a residential home, this is a snapshot right on the building code, but where it is here, but right here, residential areas, 1.9 kilopascals. So that works out to 40 pounds per square foot. Okay, so that's typical. All residential homes are 40 pounds per square foot, unless there's a project engineer that has some desire to make it more than that, but 99% of the time it's 40 pounds per square foot. Okay, so that's what we call live load. Commercial, that's where all the rest of this information becomes important, because the use of that building gauges the live load. So typical commercial office building, for example, the first floor would be 100 pounds, and then any subsequent floors above that would be 50 pounds per square foot. Okay. So it becomes important for guys like me when we want to quote on a multi-family job or a retirement home, for example. On the second floor, all the individual suites of the folks living in there would be considered residential, so that'd be 40 pounds per square foot. But all the common areas, like the kitchen, the laundry rooms, all the common areas, the meeting rooms, that would be considered commercial space, and we'd have to design that at 50 pounds per square foot. Okay, so that's where these kind of things are important. Dead load. So temporary or non-permanent load is live load, well then permanent load is dead load. Okay, so basically the weight of the structure. The weight of the structure never changes. It's always going to be the same, and it's always going to be there. That's dead load. Okay, so how much does the drywall weigh? How much does the OSB sheathing weigh? How much does the joist weigh? So all of that is the sum of all of those components that build up, that make up the floor cavity, basically, would be the dead load. Okay, so the dead load varies anywhere, depending on what you've got in your floor system. Will vary anywhere from 10 to 15 pounds. We tend to take, the worst case and design for 15 pounds per square foot. Most commonly, that's what you'll mostly see, unless you start getting into concrete toppings and things like that. So concrete toppings will add a significant amount of weight. It's so much weight for every inch of concrete. So if you have 3-inch concrete topping on it, well, it'll be an extra 30 pounds, for example. Okay. So in our literature, we've also got a table that lists the weights of the most common finishes. It's